This is our last method for solving quadratics. In hindsight, I didn't go into as much detail in the B video as like when you would want to use that. In general, I would not recommend using completing the square anytime you have a B value that's odd, or anytime you have like a greater than 1 and the other terms don't divide by it. Kind of like when we talked about that fourth example, things start to get messy. So this is our last method. This is solving using the quadratic formula, and this will work for all quadratic functions. However, it requires memorizing a formula. You are going to have this formula memorized for your paper test. And sometimes the numbers can get a little wonky, but we need this because not everything is factorable and not everything works out nicely with completing the square. So the quadratic formula gives us another way to solve quadratic equations, including those that cannot be factored. You just have a seat. Because not everything can be factored, but it still has solutions. So this is the quadratic formula right here, and it comes from that standard form. It's got B's, A's, and C's in it, and those are all going to come from your quadratic that's given to you, where A is the coefficient on x squared, B is the coefficient on x, and C is the constant at the end. It's the number without a variable. And it's going to be those values when set equal to 0. So let's look at some examples here. In number 1, I would recommend, especially in the beginning, go ahead and write down what A, B, and C are. So in number 1, A is equal to 2, B is equal to -3, and C is equal to -20. And so I'm just going to plug these three numbers into this formula here, where I see those variables, and then I'm going to follow my order of operations to simplify. The steps in which you simplify are the same for every single one. So let's look at that. X is equal, -b means I take the opposite sign. So since my b was negative, here it's going to be a +3 plus or minus. And again, that's just because most quadratics have two solutions. The square root of b squared, so -3 squared, minus 4 times a, which is 2, times c, which was -20. And then in the denominator, it's 2 times the a value. Now, I'm going to go back up here. This part right here, the part that's underneath the quadratic, this is called the discriminant. The main thing that's important about this is that whatever this value is underneath the square root, when we simplify all of this, this needs to be a positive value. When you get into higher levels of math, you'll start to talk about what to do when this comes out to be negative. But for Algebra 1, if you simplify this and you get a negative number underneath the square root, we're not at the point in math where we're taking square roots of negatives. So if you get to that, you're just going to write no real solutions. I don't have any examples on this assignment where that's the case, but it is something to be aware of. You will run into it every now and then, and we will talk about that in a warm-up in class. So now let's start simplifying. Every time you simplify this, you're following the order of operations, and so the first thing that you're going to want to do is remember that this square root right here is a grouping symbol. So I have to simplify everything that's underneath here. Basically, I have to find this discriminant before I do anything else. And I can combine steps. I can go ahead and square this and multiply these three things all in one step. So I'm going to have 3 plus or minus the square root. -3 squared is +9. We have got to remember that negatives when we square them, they become positive. And negative 4 times positive 2 times negative 20 is going to come out to be positive 160. And I can also go ahead and do this multiplication in one step. You could break it up and do those in separate steps. It's going to take up a lot more paper if you do that. So you can also just square, multiply, and multiply all at once. When I add these two together, I'm going to get 3 plus or minus the square root of 169 all over 4. And sometimes this will work out to be a whole number. And basically what that means is that you're going to end up getting either a fraction or a whole number, so this is something that would have factored. There's going to be other times, like we're going to see in example 2, where this is not something that we can take the square root of, and so that's kind of the situations where we need this quadratic formula. But in this first example, I kept our numbers nice. The square root of 169 is 13. So we have 3 plus or minus 13 divided by 4. So this right here is what's going to give us two solutions. We're going to have one solution when we do 3 plus 13 divided by 4. We're going to have another solution when we do 3 minus 13 divided by 4. So this would come out to be 16 over 4, which is 4. And this would come out to be negative 10 over 4, which simplifies to negative 5 halves. So those are our two solutions, and we write our solution set in curly brackets from least to greatest, just like on all the other ways of solving. And that's our answer. So this is one that we could have used factoring. I don't think you would have wanted to use completing the square because you would have had to divide everything by 2. This would have been a fraction, and then you would have had to divide the fraction by 2. So this would be a great example of if you're looking at a problem and you're trying to decide which method would be easiest, you would either want to factor it or use the quadratic formula. In this next example, I wouldn't want to use completing the square because, again, I'd run into having to divide everything by 9, things not dividing nicely, having fractions that I have to divide. It would get really messy, kind of like some of the spicy ones, really fast. You could check to see if it would factor, and it doesn't. So we wouldn't have any option but to use the quadratic formula. So our A value here is 9. Our B value is negative 7, and our C value is negative 4. So I'm just plug those three numbers into the quadratic formula. Opposite of B, so now it's a positive 7. All divided by 2 times A. And the process, or the steps that I followed to simplify are the same as the last time. I am going to square the negative 7. Whoops, I wrote 4AC. 4 times 9 times negative 4. Sorry, guys. So negative 4 times 9 times negative 4 will end up being plus 144. All over 18. So square, multiply, multiply. I can add these two together, and that is going to give me 7 plus or minus the square root of 193 divided by 18. Now, we're done. For this particular one, we're done. What can make the quadratic formula difficult is that I do need to check to see if this radical will simplify. So sometimes that can take some work and some time. But in this case, there are no factors of 193 that are perfect squares. I cannot simplify it. This is my answer right here. And so you can choose on your assignments if you want to leave your answer just like this and you want to put it in the curly brackets. That's how a lot of mathematicians are going to write this. They're going to write it just 7 plus or minus this over 18. It's the shortest way. If something about that doesn't feel complete to you and you want to write it out as the two separate solutions, you could also write this as 7 minus the square root of 193 over 18 and 7 plus the square root of 193 over 18. I never want to take the time to write that much, and I don't expect that you all would want to either. So either of these would be acceptable answers. Definitely don't need to write both. All right, in example 3, I'm going to need to do some moving around. I need all my terms on the same side, so I need to subtract the 8 to the other side so that this becomes 8k squared plus 7k minus 8. Most of the questions on the test, you are going to have, you're going to be told which method to use. And I'm telling you which method to use, and I'm picking out values that are going to make it easier to do that particular method. But there is going to be a section on the test where you have to decide, you know, which of these methods do I want to use. So again, on this one, you can check to see if it will factor, but it will not. And the a value is greater than 1. Well, 7 doesn't divide by 8, so then you've got this b value that's a fraction. It would just get really messy to try to complete the square with this. So on a problem like this, our best bet is the quadratic formula. So we're going to plug in, and we're going to have negative 7 plus or minus the square root of 7 squared minus 4 times 8 times negative 8. All divided by 2 times 8. And when I simplify, I have negative 7 plus or minus the square root of 49 plus 256 divided by 16. And when I add these two numbers together, I get 305, which I would need to check to see if that simplifies. But since these are notes, I can let you know that it doesn't. So that's my final answer, and I don't even have to rewrite it. I can leave it just like that. I'm going to put it in the curly brackets, make sure I have x set equal to it, and then I can circle it. I guess I forgot to circle my answer up here, but I would circle this one because that's how I would write that. All right, last example. This one's more complicated. When I look at this, I see I have m squared in two different places. I'm going to need to do some combining of like terms. I'm going to add m squared to both sides, adding it to the 8m squared since they are like terms. So I have 9m squared plus 4m minus 16 equals 0, which means I have an a value of 9, a b value of 4, and a c value of negative 16. So those are the values I'm plugging in to the quadratic formula. So x equals negative 4 plus or minus the square root of 4 squared minus 4 times 9 times negative 16, all divided by 2 times 9. And every time I write that, I always go back, and after I've written it, I double check and make sure that I put all the right numbers in all the right places and I have the right signs on everything. You do have to have this quadratic formula memorized for this test, and so I would actually recommend that each time you're doing this, until you get it memorized, before you plug it in here, I would rewrite this formula. It'll just, all those times of writing it will help commit it to memory. So now we're simplifying. Negative 4 plus or minus the square root of 16 plus 576 divided by 18. And since I'm running out of space, this simplifies to the square root of 592 divided by 18. Now, 592 has a perfect square factor. 592 is divisible by 16, so I am going to have to simplify this radical as I'm finding my final solution here. So, okay, good, it'll write over here. So the square root of 592 is the same thing as 16, or the square root of 16 times 37. And the square root of 16 is 4. So the square root of 592 is going to simplify to 4 square roots of 37. So I'm going to put that in its place. And then what makes, a lot of times that's where you're going to stop. What can make some of these that you see on the medium and the spicy extra tricky is after you simplify the radical, you also have to check to see, would this fraction simplify? And what you're looking for there is there a number that goes into this -4, this +4, and this 18? And there is. They are all divisible by 2. So this as a fraction is going to simplify even more, where I divide each of them by 2 to arrive at this final solution. So this is my final answer. I can leave it written like that, put the x equals in there, and I would circle that. So kind of similar to the completing the square assignments, if you choose the mild one, all of those work out very nicely like example 1. You are going to be able to take the square root of that discriminant value. You're going to end up with whole numbers and fractions. They're all ones that could have been factored to solve also. As you move into the medium, you're going to start to find more where you're left with a square root as part of your answer. And when you get a few of the ones on the medium, but especially on the spicy, you're going to start to find that there are quite a few that not only do you have to simplify, not only do you have a square root as part of your answer, you have to simplify the square root and you have to simplify the fraction. So that's what makes the medium and the spicy more difficult. You are likely to see a question where you do have to do all of that simplifying on the test, but I will probably give you guys some hints as to like which one that would be, just so that you're not stressing about that on all the test questions. So please make sure you complete at least one assignment from the bottom row of the choice board. You're finished with all the notes for this week. So after you finish the bottom row assignment, you should have at least one from each row, and then I would go back and I would think about which was the hardest, which one do you feel like you need more practice at, and I would complete additional assignments on those.